Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 CBCS ऑनलाइन क्लासेस रो वीडियोस गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोस गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोस रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे आमे रिजॉल्विंग पावर ऑफ ए टेलीस्कोप विषय रे पढिबा सो फर्स्ट ऑफ ऑल गोटे ऑप्टिकल इंस्ट्रूमेंट जदि आमे देखिबा मे बी सेटा टेलीस्कोप हो किंबा माइक्रोस्कोप हो सपोज आमे फॉर एग्जांपल दुईटा ऑब्जेक्ट नेला ओके सो सेही दुईटा ऑब्जेक्ट रो इमेज को आमे केमती डिस्टिंक्टली देखि परिबा that is your resolving power of that particular optical instrument, right? Now the angle which is subtended by the two objects at the eye, okay, तुम आखिरे से दुईटा ऑब्जेक्ट जेति की एंगल सबटेंड करिवो इट डिपेंड्स अपॉन द सेपरेशन बिटवीन देम ओके से दुई ऑब्जेक्ट भितरे थिबा सेपरेशन ऊपर डिपेंड करे ता सहित देयर डिस्टेंसेस फ्रॉम द आई okay so the angle may be small in either two cases. Number one, when the two objects are situated very close to each other, and number two, when the two objects may be widely separated hele bhi they are situated at large distance away, okay, for example like stars. Okay, so first example eta jo कहूची may be situated very close to each other eta microscope pai आ सेकेंड एग्जांपल जो कहूची जदियो सेमानकर भितरे डिस्टेंसटा बहुत बेसी हेले भी जदि से दुईटा जाक ऑब्जेक्ट आमठू बहुत लार्ज डिस्टेंस रे अछंती लाइक दैट ऑफ योर स्टार्स ताले एई एग्जांपलटा होची फॉर द केस ऑफ टेलीस्कोप ओके सो it is a limitation of the human eye that if this angle is less than 1 minute okay then the two objects cannot be distinguished as separate तेणु आमे से दुईटा जाक ऑब्जेक्ट को सेपरेट देखिबा पई वी यूज सम ऑप्टिकल इंस्ट्रूमेंट्स जेमति कहली ओके सो दिस ऑप्टिकल इंस्ट्रूमेंट कंसिस्ट ऑफ अ लेंस सिस्टम मे बी सेटा टेलीस्कोप हो किंबा माइक्रोस्कोप हो ओके एंड इट इज यूज्ड टू रिजॉल्व द टू ऑब्जेक्ट्स व्हिच आर पॉइंट ऑब्जेक्ट्स ओके व्हाइल जदि आमे देखिबा लाइक दैट ऑफ योर प्रिज्म एंड ग्रेटिंग these are used to resolve two very closely situated spectral lines okay spectral linespai ame use kariba prism kimba grating okay so ebe the definition ko asiba the process of separation of such closely situated objects is called resolution, right? And the ability of an optical instrument to produce their images as distinctly separate will be called as the resolving power. ओके सो ये रिजॉल्विंग पावर को एबे आउ टिके हमें डिटेल आगो बुझिबा ओके सो देखो एटा आ गुटे बही रूम नेछि रिजॉल्विंग पावर इट इज डिफाइंड एज द रेसिप्रोकल ऑफ द स्मॉलेस्ट एंगल व्हिच इज सबटेंडेड एट द ऑब्जेक्टिव ओके ऑब्जेक्टिव माने गुटे ऑप्टिकल इंस्ट्रूमेंट रे सपोज फॉर एग्जांपल इन अ सिंपल वे रे हमें जदि देखिबा टेलीस्कोप रो जो लेंसटा टुवर्ड्स ऑब्जेक्ट रहइबो दैट विल बी कॉल्ड एज ऑब्जेक्टिव okay so eta kahuchi it is defined as the reciprocal of the smallest angle which is subtended at the objective of an optical instrument by the two point objects which can just be distinguished as separate okay so jodi ei smallest angle ko ame nei gala d theta okay which is the angle subtended by the two point objects on the objective then resolving power is your reciprocal that means 1 by d theta okay and here d theta will give you the limits of resolution okay ताले एबे देखो मैग्निफाइंग पावर जदि हमें देखिबा याकू डिफाइन करि परिबा एज द रेशियो ऑफ द एंगल व्हिच इज सबटेंडेड बाय द इमेज एट द आई ओके माने रखो रिजॉल्विंग पावर पई रेशियो हमें देखुतला एक्चुअली रेसिप्रोकल देखुतला कोटार जो एंगल सबटेंड करथिला ऑब्जेक्ट एट द ऑब्जेक्टिव किंतु मैग्निफाइंग पावर पई एटा हमें देखिबा रेशियो ऑफ द एंगल सबटेंडेड बाय द इमेज एट द आई okay as seen through the optical instrument to the angle which is subtended by the object at the center of the unaided eye okay so this distance for a microscope it will be the distance of distinct vision जोटा कि निहाती भाव में 25 सेंटीमीटर रहिबो and in case of telescope it will be equal to infinity ओके सो एबे देखो या दुई भितर आम डिस्टिंक्शन जदि करबा मैग्निफाइंग पावर आउ रिजल्विंग पावर ताहले देखो फर्स्ट पॉइंट रे कहूची magnifying power is the ability of the telescope to show a magnified view of the object to the eye whereas resolving power होची ability to show the amount of detail माने केते clarity देखै परिबो ओके amount of detail or grain in the object okay second point रे कहूची magnifying power increases the distance between the centers of diffraction pattern of the two points without giving any idea of the size of central maximum whereas resolving power not only gives you the idea of the distance between the centers of two maxima but also it will give you the idea about their width okay then third point रे कहूची magnifying power of a telescope is equal to f by f capital F by small f एटी capital F हेगला focal length of objective small f हेगला focal length of your eyepiece right so now if we consider two telescopes having objectives of same diameter then they will have different magnifying powers because the focal length can be different okay magnifying power होची ratio ये जो focal length f by f but however the resolving power of a telescope which is given by the ratio d by lambda and this will be same for all telescopes having the objectives of same diameter that is d and for a given wavelength lambda of light okay then come to the fourth point resolving power increases as the wavelength of light decreases okay because यार value टा होची d by lambda whereas magnifying power is independent of the wavelength of light okay एबे এই जो resolving power को नहीं कि गोटे important जिनस आमे देखिबा the Rayleigh criterion of resolution okay so the theory of optical instruments is based on the laws of geometrical optics and rectilinear propagation of light and these laws are only approximately true okay পাখাপাখি এটা valid রহিব now when a beam of light passes through an objective of a telescope then the lens will act like a circular aperture and produces a diffraction pattern okay जोटा हमें previous class रे देखिला so instead of a point image we are getting what a diffraction pattern and this pattern will be having a bright point surrounded by alternate dark and bright rings okay so if there are 2 point objects which are lying very close to each other then the two diffraction patterns which are produced will maybe there are chances of overlapping okay as you can see here in this figure so Rayleigh criterion ta kono Rayleigh criterion kohuchi the two images of such point objects lying very close to each other are said to be separated or you can say just resolved okay if the central maximum of one falls on the first secondary minimum of the other okay this is a very important statement so in other words when the central bright image of one falls on the first dark ring of the other okay and this is what shown in the figure so देखो एटी figure रे ये जो बोल्ड लाइन रो फर्स्ट एटी तुम सेंट्रल मैक्सिमम देखुछ ओके এই সেন্ট্রাল ম্যাক্সিমামটা এই ডটেড লাইনর ফার্স্ট মিনিমম উপরে এটা ওভারল্যাপ করিছি সিমিলারলি अगेन उल्टा जिनस ए देखा ये डटेड लाइनर सेंट्रल मैक्सिममटा ये बोल्ड लाइनर फर्स्ट मिनिमम उपरे ओवरलैप करिछि सो दैट वी कैन सी द टू images of the point objects like this okay and we can say they are just distinguished as separate okay and beyond that there will be overlapping, we cannot have detailed clarity of the images, right? So this criteria of resolution is equally applicable to the resolution of spectral lines of equal intensity. Okay, so সেটা point object ho কিংবা spectral lines ho, this Rayleigh criterion is equally applicable. So two closed spectral lines in the spectrum are said to be just resolved when the central maximum of the diffraction pattern of one will fall on the first minimum of diffraction pattern of the other. That is, the least angular separation between the principal maxima of the diffraction pattern of two spectral lines in a given diffraction order should be equal to half of the angular width of either principal maximum, right? So resolving power को এই केस रे आमे लिखि परिबा lambda by d lambda. एटी lambda हेगला obviously the wavelength of a line in the spectrum, ଆଉ d lambda हेगला it is the difference in the wavelength that can be just distinguished as separate. So resolving power केते हैला, it is equal to lambda by d lambda, right? So this is all about the resolving power and the Rayleigh criterion. Now let us come to the main topic, the resolving power of a telescope. So first of all, ame janichu a telescope is used to see the distance object. Okay, amuthu bahut durare thiba object ku dekhiya pai we use the telescope. Therefore the details of the two point objects can be viewed, and it depends on the angle which is subtended at the objective of the telescope by the two point objects rather than the linear separation between them. Okay, semanko bhitere kete distance अछि ता उपरे एते डिपेंड करेनी, केते एंगल सबटेंड करूची ऑब्जेक्ट उपरे ता उपरे एई दुईटा जाको पॉइंट ऑब्जेक्ट रो इमेज टा डिपेंड करिवो. ओके, सो याकू बुझिबा पई हेले लेट अस कंसीडर the figure here. Okay, suppose we have taken the objective AB of the telescope and let us say its diameter is capital D. Now let us take two distant objects O and O dash. Okay, solid line एठी दे दबा object O पाई आउ dotted line एठी दबा आमे object O dash पाई, right? So object O आउ O dash एटा बहुत बेसी दूरता रे अछंती from this objective and they are subtending a very small angle. This angle is d theta, right, at the objective of the telescope. Now a parallel beam of light from the object O, first ame ei solid line को consider करिबा. You can see this is a parallel beam of light because the object is at a very large distance from the objective. So this parallel beam, upon refraction through this objective lens, it will be focused at this point P. Okay, as this parallel beam is incident normally on the objective, right? But however here the objective will serve as the circular aperture and thereby will produce a Fraunhofer diffraction pattern. So instead of getting a point image, what we will get? We will get a Fraunhofer diffraction pattern which is consisting of the central bright disk surrounded by alternate dark and bright rings. So this point P will be a central bright spot and it is surrounded by alternate dark and bright rings, right? So same situation will happen for the second object, that is O dash. एठी भी parallel beam आसिला, lens रे refraction हैला and it will be focused at this point P dash, but however as this lens will be acting as circular aperture, so we are again getting a Fraunhofer diffraction pattern, right? So as per Rayleigh criterion of resolution, these two diffraction patterns, as you can see, they are overlapping with each other. दुई जन को भितरे दुई pattern भितरे overlapping होउची. So as per Rayleigh criterion, the images can be viewed as just distinguished as separate, that is just resolved केतेबेले ना if the central maximum of one will coincide with the first secondary minimum of the other, जोटा आमे ऊपर देखिला, and vice versa. So एठी आमे angle जदि देखिबा PAP dash, this small angle will be again d theta, right? and also angle BAN. This angle will also be d theta. So एठी आमे path difference जदि आमे calculate करिबा between the secondary waves which are traveling in the direction AP dash and BP dash. Okay, ए जो dotted line टा देखुछ ହେଲା AP dash ଆଉ BP dash এই দুই ভিতরে ଆମେ path difference बाहर करिबा ताले this is nothing but BN. Okay, now this path difference BN will be equal to BP dash minus AP dash. Okay, and as you can see this triangle ABN is a right angle triangle, so BN by AB will be sine d theta, or we can say BN will be equal to AB d theta. Okay, so एठी हमें rule use करछु sin d theta is nearly equal to d theta because the angle d theta is very small. Okay, ताले हमें path difference पाई गला केते BN equal to d into d theta. Okay, capital D ही गला एठी diameter of the objective. Okay, so एबे ए जो path difference को हमें यदि कहबा it is equal to lambda, then the first minimum of P dash will fall on the central maximum of P, and therefore as per Rayleigh criterion this will be the required condition which is fulfilled, and the objects that is O and O dash will be just resolved. Okay, এটা revolved হবনি resolved হব, that means they will be just distinguished as separate. So आमे नहीं जबा एठी path difference equal to lambda आउ याकू इक्वेट कर दबा d into d theta सहित, ताले आमे केते पाइला d theta equal to lambda by capital D. Okay, so since the limit of resolution of the telescope is equal to this small angle d theta, so आमे एटा पाई गला lambda by d. And however if Airy's formulation is considered, okay, Airy याकू आटिके modified कले जोटा हमें circular aperture भी पड़ीथिला, so सेथिरे गोटे फैक्टर हमें एथिरे इंट्रोड्यूस करिबा 1.22 जोटा को हमें न्यूमरेटर रे मल्टीप्लाई करिबा. Okay, so d theta will be equal to 1.22 lambda by capital D. Hence resolving power is ebe kete reciprocal of this limit of resolution, that is 1 by d theta. So capital D by 1.22 lambda. Okay, yaro value ta asila, which shows that the resolving power depends upon the diameter of the objective, that is capital D, and the wavelength lambda of light. Okay, but however focal length upare eta depend karu nahi. Therefore for greater resolution objective of telescope should have large aperture. Large aperture jodi hegala tale diameter bi modhyo yara bodhi jibo. Okay, and if the radius of the central bright disk is equal to suppose small r, आउ जदि आमे नहीं गला focal length of objective of telescope को small f, ताले देखो आमे एठी d theta को लिखि परिबा as the ratio r by f. Okay, using angle equal to arc by radius. এই formula भी हमें देखी थिला जो previous class रे circular aperture case रे. Okay, so एठी r by f equal to 1.22 lambda by capital D, or r equal to 1.22 lambda f by capital D. Okay, hence एठी जो r होची कोन separation between the two objects. Okay, so we can calculate this separation by using this formula. Okay, and this separation r depends upon three factors: lambda, f and d. Okay, r is directly proportional to lambda and f, but inversely proportional to the diameter d. So a point here to remember is that more will be the diameter of the objective of telescope, more will be the resolving power of this telescope. Okay, so this is all about the resolving power of a telescope. Thank you.